I'm so glad you found your way here. Welcome to Get Sleepy Science. Every winter night, your brain produces 30 more minutes of dream sleep than it does in summer, a hidden gift from the season of darkness. Tonight, you'll discover why cold months cradle you into deeper rest. And by the end, you'll understand why winter is your body's natural invitation to heal. Wherever you are right now, perhaps wrapped in blankets while frost patterns bloom on windows, or simply feeling the quiet stillness that only winter brings, allow yourself this moment of peace. We'll journey through 100 sleepy facts about how seasons shape your sleep, from the brain chemistry that shifts with shorter days, to the body temperature that guides you into dreams, to the ancient rhythms your cells still remember. These calm explorations of winter's sleeping wisdom plant seeds of tranquility in restless hearts. Feel free to like and subscribe or share a thought down in the comments. It helps others find their way here too, one sleepy soul at a time. Your presence here nurtures our growing forest of peace. Sink into your favorite resting spot. Allow your muscles to release, each breath growing softer. There's no need to remember these winter facts. Just notice that warm, drowsy calm washing over you, like gentle snowfall settling on silent ground, each flake drawing you deeper into restful, effortless sleep. Close your eyes and breathe deeply. You're floating where memories rest safely in gentle darkness. Let your mind merge with infinite peace. And now we begin. Your brain creates 30 more minutes of REM sleep, the dream-filled stage of rest, during winter nights than it does in summer. Scientists at St. Hedwig Hospital in Berlin discovered this remarkable pattern in 2023 when they studied sleep data from 188 people across an entire year. REM sleep is the stage where your eyes move rapidly beneath closed lids, your heart rate quickens, and vivid dreams unfold. It's also when your brain consolidates memories, regulates emotions, and strengthens your immune system. The increase happens naturally, without any conscious effort on your part, as your pineal gland responds to longer periods of darkness. Winter nights wrap your sleep in deeper layers of restorative dreaming, as if the season itself understands what your body needs. This is recent scientific confirmation of something older cultures sensed. Winter is the time for deeper rest. Analysis of sleep data from Oura ring wearers in 2024 revealed that people sleep about 3% longer in winter, roughly 10 extra minutes per night. That might not sound like much at first, but across a 3-month winter season, it adds up to 15 hours of additional restorative sleep, your body quietly claims. Time spent in bed increases from slightly less than 8 hours in summer to 8 hours and 15 minutes in winter. Your body isn't being lazy during these darker months. It's responding to an ancient biological rhythm that recognizes winter as a season for repair and restoration. Those extra minutes allow your cells more time to clear away metabolic waste, your immune system more time to strengthen its defenses, and your brain more time to organize the day's experiences into lasting memories. Even small increases in sleep duration can significantly improve how refreshed you feel upon waking. During winter, your circadian rhythm, your internal 24-hour clock, naturally phase delays by about 30 minutes compared to summer. This shift was documented in a 2019 study from Novosibirsk, Russia, where researchers measured melatonin levels in people's saliva throughout both summer and winter. Your suprachiasmatic nuclei, a tiny cluster of about 20,000 cells in your hypothalamus, acts as your master timekeeper. In summer, with its long photoperiods, this clock synchronizes tightly with the external light-dark cycle. But in winter, the prolonged darkness permits your internal clock to drift slightly, creating more individual variation in when different people feel sleepy or alert. The phase delay means you might naturally feel ready for sleep a bit later than you did in summer, even as you also sleep longer overall. your body exploring a more flexible relationship with time during the season when daylight is scarce. Your pineal gland, a small pine cone-shaped structure deep in your brain, produces melatonin, the hormone that signals nighttime to your body. During winter's longer nights, this gland secretes melatonin for extended periods, flooding your bloodstream with levels that are 10 to 15 times higher than daytime concentrations. The chemical process begins when darkness triggers your suprachiasmatic nuclei to reduce their inhibition of the pineal gland. Special enzymes called AANAT and ASMT then convert serotonin into melatonin through a precise biochemical pathway. Peak melatonin levels typically occur around 3 to 4 in the morning, creating the deepest point of nighttime rest. In winter, because darkness arrives earlier and lingers later, your body starts this melatonin rise earlier in the evening and maintains it longer into the morning. This extended melatonin signal tells every cell in your body that it's time for sustained restoration, not just brief overnight repair. Your core body temperature needs to drop about 2 degrees Fahrenheit before you can easily fall asleep. Winter's cooler ambient temperatures naturally assist this process, which is why research from 2024 found that people fall asleep faster when their bedroom temperature is between 60 and 67 degrees Fahrenheit. A study using temperature-controlled mattress covers showed that cooling the body during the first half of the night decreased sleep latency, the time it takes to drift off, by several minutes. This happens because your body's thermoregulatory system interprets the cooling environment as a signal that nighttime has arrived, even if you're indoors with artificial light. Blood vessels in your hands and feet dilate to release heat from your core, a process called distal vasodilation. As your core cools, your brain receives the message that conditions are optimal for sleep, making it easier to let go of waking consciousness and slip into restful slumber. When winter solstice arrives, typically between December 20th and 22nd in the northern hemisphere, daylight in northern regions shrinks to just 8 or 9 hours, while darkness expands to 15 or 16 hours. Your body recognizes this shift through specialized cells in your retina called intrinsically photosensitive retinal ganglion cells. These cells contain melanopsin, a photopigment that's especially sensitive to the blue wavelengths present in daylight. They send signals directly to your suprachiasmatic nuclei, informing your master clock about the length of the day. Throughout human evolution, winter meant scarcity, cold, and the need for energy conservation. Your ancestors who slept longer during winter months preserved calories and stayed sheltered during the extended darkness when traveling was less practical. Though modern life has electric lights and heated homes, your biology still carries this ancient program, quietly encouraging you toward more rest when days are short. A 2024 study on temperature-controlled sleeping found that men experienced an average of 14 additional minutes of deep sleep when their beds were cooled during the first half of the night. Deep sleep, also called slow-wave sleep or stage 3 non-REM sleep, is when your brain waves slow to their lowest frequency, less than 3 cycles per second. During this stage, your pituitary gland releases growth hormone, your immune system strengthens its cellular defenses, and your brain clears away toxic proteins that accumulated during waking hours. The cooling effect seems particularly effective for men, possibly due to differences in body composition, metabolism, or thermoregulatory responses. Winter's natural temperature drop mimics this cooling intervention, supporting your body's descent into these profoundly restorative sleep stages. Think of deep sleep as your body's maintenance mode, and winter as the season that gives you more time in that essential mode. The same 2024 temperature study found that women gained 9 additional minutes of REM sleep when sleeping in cooler environments during winter months. While men showed stronger responses in deep sleep stages, women's brains appeared more sensitive to temperature changes during the REM phase. REM sleep is characterized by rapid eye movements, increased brain activity similar to waking states, and vivid, narrative dreams. This stage plays a crucial role in emotional regulation, creative problem-solving, and memory consolidation, especially for procedural and emotional memories. For women, the extra REM sleep provided by winter's natural cooling may offer enhanced emotional processing and mood regulation, both particularly valuable during seasons when daylight exposure is limited and seasonal mood changes are common. The sex differences in these responses highlight how men's and women's sleep architectures respond uniquely to environmental temperature changes throughout different seasons. Data from millions of Oura Ring users in 2024 showed that resting heart rate increases by approximately 3% during winter months, about 1.5 to 1.8 beats per minute on average. While this might seem counterintuitive, since you're resting more, it actually reflects your body working slightly harder to maintain core temperature in cooler environments. Your cardiovascular system adjusts its baseline activity to support thermoregulation, circulating warm blood to your extremities more frequently to prevent heat loss. Interestingly, despite this small increase in heart rate, sleep quality often improves during winter. The combination of longer sleep duration, more REM sleep, and cooler sleeping conditions creates a net positive effect on overnight cardiovascular recovery. Your heart still gets the restoration it needs. It just operates at a slightly higher baseline while delivering that restoration, much like a furnace that runs more often, but still provides comfortable warmth throughout a winter home. Heart rate variability, the variation in time intervals between consecutive heartbeats, drops by about 8% during winter months, from an average of 45.7 milliseconds in July to 42.5 milliseconds in January. This metric reflects your autonomic nervous system's flexibility, with higher variability generally indicating better stress resilience and cardiovascular health. The winter decrease appears to be a normal seasonal adaptation as your body shifts toward a more consistent, conservation-oriented physiological state. Think of it as your nervous system tightening its responses for efficiency rather than maintaining the broad adaptability needed during more active seasons. Throughout human evolution, winter required steady, enduring effort rather than quick, varied responses to changing conditions. Your heart rate variability reflects this ancient pattern, becoming more regular and predictable when survival depended on conserving energy rather than rapidly responding to immediate challenges in your environment. A survey from the American Academy of Sleep Medicine found that 34% of American adults report sleeping more during winter months. The phenomenon occurs across different climates and latitudes within the United States, suggesting it's driven more by photoperiod changes and cultural winter patterns than by temperature alone. People describe feeling naturally drowsier earlier in the evening, having more difficulty waking to morning alarms, and experiencing stronger desires for weekend sleep-ins during December through February. This collective experience validates what individual sleep data has shown. Winter genuinely does invite longer sleep. Recognizing this as normal rather than problematic can reduce the guilt or frustration many people feel about needing more rest during darker months. Your body isn't failing you. It's following an ancient seasonal wisdom that has guided human sleep patterns for thousands of years. Approximately 1/3 of American adults have vitamin D levels below optimal ranges, and this deficiency increases the risk of sleep disorders by 50%, according to meta-analysis research from 2018. Vitamin D receptors are widely distributed throughout brain regions involved in sleep regulation, including your hypothalamus, which houses the suprachiasmatic nuclei controlling your circadian rhythm. The vitamin plays a crucial role in the production pathway of serotonin, which your body then converts into melatonin. When vitamin D levels drop, as they commonly do in winter when sunlight is weaker and daylight hours are limited, this entire sleep-regulating cascade can become disrupted. People with vitamin D deficiency report poorer sleep quality, shorter total sleep duration, increased sleep latency, and more daytime sleepiness. Winter sunlight in northern latitudes is too weak for your skin to synthesize adequate vitamin D, which is why health authorities recommend supplementation between October and March at doses around 1,000 to 2,000 international units daily. Research tracking sleep patterns across multiple seasons found that sleep duration modestly decreases when day lengths get longer between winter and summer solstices, and increases again as days shorten from summer back toward winter. Your body measures the duration of melatonin secretion each night, and this biochemical signal conveys seasonal information to your cells. In summer, with only 8 or 9 hours of darkness, melatonin secretion is compressed into a shorter window. In winter, with 15 or 16 hours of darkness, melatonin secretion extends across a longer period. Your cells interpret this extended melatonin signal as winter's message to prioritize restoration over activity. The pattern emerges consistently across different populations, suggesting it's a deeply conserved aspect of human biology that artificial lighting hasn't fully overridden, even in our modern, electrically lit world. Research on sleep neuroscience shows that cold, dark winter conditions affect the activity of orexin neurons in your lateral hypothalamus, specialized cells that promote wakefulness. These neurons normally respond to light and rising body temperature by releasing chemicals that make you feel alert and ready to engage with your environment. In winter's dim mornings, however, these neurons remain relatively quiet for longer periods, contributing to that characteristic winter grogginess many people experience. Your core body temperature, which naturally rises in preparation for waking, also increases more slowly when ambient temperatures are cool. The combination creates a physiological state where your brain and body transition from sleep to wakefulness more gradually, more gently than during summer's bright, warm mornings. Your nervous system responding appropriately to seasonal environmental conditions that historically signaled less urgent reasons to rise. Seasonal affective disorder, which affects approximately 10 million Americans, significantly alters sleep patterns during winter months. People with SAD experience an average of 2.7 additional hours of sleep during winter compared to summer. Along with changes in sleep architecture, the proportion of time spent in different sleep stages. Research shows individuals with SAD often have less deep sleep and proportionally more REM sleep during winter months, creating an imbalance that contributes to daytime fatigue despite extended time in bed. The disorder is thought to result from misalignment between internal circadian rhythms and external light-dark cycles, combined with disrupted melatonin regulation. Light therapy. Exposure to bright light of at least 10,000 lux for 30 minutes each morning remains the primary treatment, essentially providing an artificial summer dawn to realign circadian rhythms. Understanding SAD helps illustrate how profoundly seasonal light changes affect sleep, even in people without the disorder who experience milder versions of the same biological shifts. Large-scale research involving over 34,000 participants found that sleep efficiency, the percentage of time in bed actually spent sleeping, begins to decline when bedroom temperatures exceed 60 degrees Fahrenheit. The most recent analysis from 2025, examining billions of sleep measurements from 68 countries, confirmed that higher nighttime temperatures specifically reduce people's ability to fall asleep and stay asleep throughout the night. Your body needs to shed heat to initiate sleep, and an overly warm environment interferes with this essential process. Conversely, extremely cold temperatures below 60 degrees can also disrupt sleep by activating your body's cold-sensing neurons, and triggering shivering thermogenesis. The optimal range, between 60 and 67 degrees, represents the zone where your body can most easily regulate its core temperature without expending excessive energy, either heating or cooling itself. Winter naturally pushes bedroom temperatures into this optimal range, especially in homes where thermostats are lowered at night to conserve energy. A comprehensive 2025 study, published in Nature Communications, observed that climate change may gradually shift winter sleep patterns. Researchers analyzed 23 million days of sleep data from over 200,000 participants across mainland China, and noted that for each 10 degrees Celsius increase in ambient temperature, total sleep duration decreased by 9.67 minutes, with deep sleep declining the most, by 2.82 minutes. Under various future scenarios, researchers projected that as winters grow warmer, the natural temperature differences that support deeper winter sleep may become less pronounced over time. This research highlights how winter's natural sleep benefits depend on genuine seasonal temperature differences. The study adds sleep disruption to the growing list of health effects associated with our changing climate, though the full implications remain an area of ongoing scientific investigation. During winter, when natural daylight is limited to 8 or 9 hours, the timing of your light exposure becomes critically important for maintaining healthy sleep patterns. Morning light exposure, even from dim winter sunshine, helps anchor your circadian rhythm and prevent excessive phase delay. Your melanopsin-containing retinal cells are most sensitive to light during the morning hours, when exposure advances your biological clock and promotes earlier sleep onset that evening. Conversely, evening light exposure during winter can significantly delay your circadian rhythm, making it harder to fall asleep at a reasonable hour. This effect is particularly pronounced with blue-enriched light from electronic screens. A 2024 study on pre-sleep lighting found that correlated color temperature, the blue versus warm content of light, predominantly influences sleep latency, while illuminance level primarily affects sleep duration and perceived quality. Winter's reduced natural light makes your eyes more sensitive to artificial light at night, amplifying its sleep-disrupting potential. Taking a warm bath or shower 1 to 2 hours before bedtime can improve your ability to fall asleep, especially during winter months. When you immerse yourself in warm water, your blood vessels dilate, bringing warm blood to your skin's surface. Upon emerging from the bath, this dilated vasculature facilitates rapid heat dissipation, causing your core body temperature to drop faster than it would naturally. This accelerated temperature decrease mimics and amplifies the natural circadian decline in core temperature that signals sleep onset. The effect is particularly pronounced during winter, when the temperature differential between the warm bath and cool bedroom air is greatest. Additionally, the relaxation response triggered by warm bathing activates your parasympathetic nervous system, reducing stress hormones and promoting the calm physiological state conducive to sleep. The ritual itself can become a powerful sleep cue, signaling to your brain that bedtime is approaching. From December through February in northern temperate regions, nighttime darkness lasts 15 to 16 hours, creating an extended window for potential sleep. While most people don't sleep this entire period, the prolonged darkness removes external pressure to wake and allows your body to complete full sleep cycles without artificial interruption. Each complete sleep cycle lasts approximately 90 minutes, progressing through light sleep, deep sleep, and REM sleep before returning to light sleep and potentially beginning again. With 16 hours of darkness, your body could theoretically complete up to 10 sleep cycles, though most adults naturally complete only 4 to 6. The extra time allows your sleep to be less rushed and more responsive to your body's actual restoration needs rather than alarm clock demands. Historical evidence suggests that before electric lighting, humans commonly experienced segmented sleep, two distinct sleep periods, separated by a quiet waking interval during long winter nights. Your breathing pattern shifts slightly during winter sleep compared to summer rest. The cooler, drier air of winter bedrooms can affect your respiratory rate and depth of breathing. Research shows that people tend to breathe slightly slower and more deeply during winter sleep, a pattern that supports parasympathetic nervous system activity and deeper relaxation states. The body naturally adjusts breathing to maintain optimal oxygen and carbon dioxide balance across different temperature conditions. Nasal breathing, which warms and humidifies air before it reaches your lungs, becomes particularly important during winter, when bedroom air tends to be drier. This slower, deeper breathing pattern during winter sleep may contribute to the subjective feeling of more restful sleep that many people report during colder months. Your respiratory system quietly adapting to seasonal conditions while you dream. Winter air, both outdoors and inside heated homes, tends to be much drier than summer air. Indoor relative humidity often drops below 30% during winter months in heated homes. Sleep researchers suggest maintaining humidity between 30 and 50% for optimal respiratory comfort, though individual preferences vary. Dry air can dry out the mucous membranes in your nose and throat, sometimes causing discomfort that disrupts sleep or triggers nighttime coughing. However, winter's lower humidity also means less muggy, heavy air that can interfere with comfortable breathing. A small humidifier can help achieve this balance, providing enough moisture to keep airways comfortable without creating the damp, stuffy feeling that impairs sleep quality. Some studies suggest that maintaining optimal humidity levels during winter sleep may support your respiratory system's natural defense mechanisms. The key is finding the humidity sweet spot, where breathing feels easiest throughout the night. In winter, natural daylight, which contains the full spectrum of light, including blue wavelengths, is available for fewer hours each day. While this reduces overall light exposure, it also means less natural blue light reaching your eyes during morning and daytime hours. Blue light, with wavelengths around 460 to 480 nanometers, is particularly effective at suppressing melatonin production and promoting alertness. The relative absence of natural blue light during short winter days can contribute to winter drowsiness and difficulty maintaining wakefulness. However, this same reduction in blue light exposure makes your eyes more sensitive to the blue light from electronic devices after dark. A smartphone or tablet that might have minimal sleep-disrupting effect on a summer evening can significantly delay melatonin onset during winter, when your eyes have adapted to lower overall light levels. This heightened sensitivity means practicing screen time boundaries becomes even more important for winter sleep quality. The comforting weight of heavy blankets during winter months may provide more than just warmth. Research on deep pressure stimulation suggests that the gentle distributed weight of winter bedding can activate your parasympathetic nervous system, promoting relaxation and reducing cortisol levels. This pressure creates a sensation similar to being held or hugged, triggering the release of serotonin and dopamine while decreasing stress hormones. Weighted blankets, typically between 15 and 25 pounds, have been shown to improve sleep quality and reduce anxiety in some individuals. During winter, when people naturally layer heavier blankets and comforters, this beneficial pressure occurs organically. The weight provides proprioceptive input, information about your body's position in space, that can be grounding and calming. Your body nestled securely under winter bedding, feeling both physically and psychologically safe enough to release into deep sleep. Archaeological and anthropological evidence suggests that humans have followed seasonal sleep patterns for tens of thousands of years. Studies of modern hunter-gatherer societies living without electricity show they sleep approximately 1 hour longer during winter months, going to bed earlier and waking later, mirroring the patterns seen in contemporary sleep research. Before the Industrial Revolution and widespread artificial lighting, winter was universally recognized as a time for extended rest, indoor activities, and reduced physical exertion. Historical records describe how agricultural societies structured their work around seasonal daylight, with winter months devoted to indoor crafts, storytelling, and extended sleep periods. The biological mechanisms driving your increased winter sleep duration today, melatonin responses to longer darkness, temperature effects on sleep stages, and vitamin D fluctuations, are the same mechanisms that guided your ancestors' sleep for millennia. Your body's response to winter is an ancient pattern temporarily obscured by electric lights and central heating. Take a deep breath and feel this. Every atom in your body, the carbon, the oxygen, the iron, was created in the core of a dying star billions of years ago. The warmth you seek under winter blankets, all made from the material of the universe, seeking the material of warmth. Feel yourself carrying the trace of ancient stars. Every breath you take connects you to all breathing beings, those sleeping now in winter darkness across the planet. We are all following the same ancient rhythm, the same seasonal dance between light and dark. You're not separate from nature. You are nature, responding perfectly to winter's invitation. Now we continue. Adenosine, a neurotransmitter that builds up in your brain throughout waking hours, creates increasing sleep pressure that makes you feel progressively drowsier as the day continues. During winter months, when daylight hours are shorter and activity levels often decrease, adenosine may accumulate at a slightly different rate than in summer. Your neurons use adenosine triphosphate for energy, and as they break it down, adenosine byproducts accumulate in your brain. This buildup inhibits wake, promoting neurons, and activates sleep-promoting ones. In winter, with less light-driven alertness and cooler temperatures that encourage rest, your body may process adenosine in ways that support earlier sleep onset and longer sleep duration. The molecule acts like an hourglass measuring your waking time, and winter's rhythm may simply turn that hourglass to accommodate more sand, more rest. The glymphatic system, your brain's waste clearance network, operates primarily during sleep, flushing out metabolic debris and toxic proteins that accumulate during waking hours. With winter's longer nights and extended sleep periods, this system has more time to perform its essential cleaning functions. Cerebrospinal fluid flows through your brain tissue during sleep, carrying away waste products, including beta amyloid and tau proteins, associated with neurodegenerative diseases. The system is most active during deep sleep stages, when your neurons shrink slightly to allow better fluid flow through the spaces between cells. Winter's enhancement of deep sleep duration, particularly in men, may provide extended opportunities for this crucial brain maintenance. Think of it as your brain getting a longer, more thorough cleaning session each winter night, flushing away the day's cellular debris more completely. Cortisol, often called the stress hormone, follows a daily rhythm that typically peaks in the early morning to help you wake up and gradually declines throughout the day. Research from Swedish office workers showed seasonal variations in this pattern, with higher morning cortisol levels observed during late winter and spring months, February through April, and lower levels during summer months of July and August. This seasonal cortisol pattern may reflect your body's adaptive response to winter's demands, providing extra energy to overcome the natural grogginess of dark mornings. Interestingly, despite these higher morning peaks, overall sleep quality often improves during winter, suggesting your body successfully balances the need for morning activation with the benefits of extended nighttime rest. Your endocrine system, dancing with the seasons, adjusting its rhythms to match the world outside. Growth hormone, essential for tissue repair, muscle development, and metabolic regulation, is released primarily during deep sleep stages. With winter's natural enhancement of deep sleep duration, particularly the 14 extra minutes observed in men, your pituitary gland has more opportunity to secrete this vital hormone. Growth hormone release typically occurs during the first major deep sleep cycle of the night, usually within the first 90 minutes after falling asleep. The hormone stimulates protein synthesis, reduces protein breakdown, mobilizes fat stores for energy, and supports immune function. During winter, when your body faces additional demands from cold exposure and reduced daylight, this enhanced growth hormone secretion may help maintain physical resilience. Your pituitary gland recognizing winter as a season for building and repairing, making the most of those extended dark hours. Your cells contain clock genes, CLOCKBMAL1, PER, and CRY, that oscillate in roughly 24-hour cycles, controlling countless physiological processes. These genes don't just respond to light and dark, they also show seasonal variations in their expression patterns. Research has identified that the timing and amplitude of these genetic oscillations can shift between summer and winter, affecting everything from metabolism to immune function to hormone release. In winter, with its extended darkness, the expression of certain clock genes may sustain longer or shift in timing, supporting the physiological changes that promote longer sleep. These genes essentially write the instruction manual for your daily rhythms, and winter appears to edit that manual slightly, adding pages that encourage extended rest. Molecular timekeepers throughout your body, reading and responding to winter's unique light signature. Your immune system performs crucial maintenance and enhancement work during sleep, and winter's longer sleep periods may provide additional time for these protective processes. During sleep, your body produces and distributes cytokines, proteins that help fight infection and inflammation. Sleep deprivation reduces production of these protective proteins, while adequate sleep supports robust immune responses. Winter's combination of longer nights, more REM sleep, and enhanced deep sleep may help explain why well-rested individuals better resist the seasonal illnesses that circulate during colder months. Your immune cells communicate more effectively, antibodies circulate more efficiently, and inflammatory processes balance more appropriately when you get sufficient sleep. Winter offering your immune system extended nighttime hours to strengthen its defenses, preparing you for the season's unique challenges. The biochemical pathway that converts serotonin into melatonin operates more extensively during winter's longer nights. Serotonin, often associated with mood and well-being during waking hours, serves as the direct precursor to melatonin. The enzyme AANAT facilitates this conversion, and its activity is primarily nocturnal, ramping up when darkness signals your pineal gland to begin melatonin production. During winter, with 14 to 16 hours of darkness, this conversion process can continue for an extended period, producing more total melatonin across the night. This sustained melatonin production creates the biochemical environment necessary for longer sleep duration and enhanced REM sleep. Interestingly, vitamin D plays a role in serotonin synthesis, which may help explain why winter's vitamin D deficiency can disrupt the entire sleep-regulating cascade, one molecule transforming into another, guided by darkness. Brown adipose tissue, unlike regular white fat, generates heat through a process called thermogenesis. When activated by cold exposure, brown fat burns calories to produce warmth, particularly during sleep when other metabolic processes slow. Research shows that people sleeping in cooler temperatures, around 66 degrees Fahrenheit, show increased brown fat activity and improved metabolic markers. During winter, when bedroom temperatures naturally drop and ambient cold exposure increases, your brown fat may activate more readily, contributing to the comfortable thermal balance that supports quality sleep. The heat generated by brown fat creates a gentle internal warmth that contrasts pleasantly with the cool sleeping environment, potentially enhancing the temperature gradient that promotes sleep onset and maintenance. Your body literally burning energy to keep warm while you dream. Theta brainwaves, oscillating at 4 to 8 cycles per second, characterize the transition between wakefulness and sleep, as well as certain phases of light sleep and dreaming. Some research suggests that winter sleep may feature slightly more time in theta states, creating that characteristic feeling of deep relaxation and gentle drift toward slumber. These waves are associated with creativity, memory consolidation, and the hypnagogic state, that twilight zone between waking and sleeping, where unusual thoughts and images arise. The extended darkness of winter nights may allow your brain more time to linger in these theta-rich states, neither fully awake nor completely asleep, but floating peacefully between. An electroencephalograph would show these slower waves rippling across your cortex like gentle ocean swells, calming and rhythmic, throughout winter's long dark hours. Sleep fragmentation, the number of times you briefly wake during the night, often without remembering, tends to decrease during winter months for people sleeping in optimal temperature conditions. Research tracking sleep continuity found that cooler sleeping environments between 60 and 67 degrees Fahrenheit reduce the frequency of micro-arousals that disrupt sleep architecture. These brief wakings, lasting only seconds, can accumulate to significantly degrade sleep quality, even when total sleep time appears adequate. Winter's naturally cooler ambient temperatures, combined with appropriate bedding choices, create conditions where sleep flows more smoothly from cycle to cycle without the interruptions that fragment rest. Your consciousness remaining more stable in its sleeping state, unperturbed by the small disturbances that might wake you on warmer nights. Winter gifting you not just longer sleep, but more continuous, less interrupted rest. Your body contains two primary types of melatonin receptors, MT1 and MT2, distributed throughout your brain and peripheral tissues. These receptors respond to melatonin by initiating various sleep-promoting and circadian regulating processes. Some evidence suggests that during winter, when melatonin exposure is prolonged each night, these receptors may become more sensitive or upregulate their numbers, responding more readily to the hormone's signals. The MT1 receptors primarily influence sleep onset, while MT2 receptors affect circadian phase shifting and rhythm entrainment. Enhanced receptor sensitivity during winter could help explain why sleep onset sometimes occurs more easily, despite the challenges of reduced daylight and potential vitamin D deficiency. Your cells becoming better listeners to melatonin's nighttime message, responding more readily to its gentle invitation to rest. Research on sleep positions reveals that people adjust their posture during sleep in response to thermal comfort. During winter months, when sleeping environments are cooler, individuals tend to adopt more curled or fetal positions, reducing surface area exposed to cool air and conserving body heat. Conversely, summer's warmer nights encourage more sprawled sleeping positions that maximize heat dissipation. These unconscious adjustments happen throughout the night as your body continuously monitors its thermal state and makes micro-adjustments to maintain optimal sleeping temperature. Winter sleep might find you curled under blankets, knees drawn up, perhaps with hands tucked near your chest, an ancient mammalian response to cold that dates back millions of years. Your sleeping body still an animal body, knowing instinctively how to stay warm and safe through the longest nights. The pineal gland, your body's melatonin factory, tends to accumulate calcium deposits with age, a process called calcification. While this can impair melatonin production in some individuals, winter's extended darkness periods may partially compensate for age-related declines in pineal function. Even a calcified pineal gland can still produce melatonin, It just does so less efficiently. During winter's 14 to 16 hours of darkness, the extended time window for melatonin synthesis may allow even compromised pineal glands to produce adequate amounts. This might help explain why some older adults, who often struggle with sleep, report slightly better sleep quality during winter months, despite having more pineal calcification than younger individuals. The season's extended darkness offering a margin of grace, extra time for the pineal gland to complete its nightly work. Sleep spindles, brief bursts of brain activity during light sleep, appearing as distinctive waveforms on EEG recordings, play important roles in memory, consolidation, and protection of sleep from external disturbances. Some research suggests that cooler sleeping temperatures may increase the frequency or amplitude of sleep spindles, enhancing their protective and memory consolidating functions. These spindles, lasting 1 to 2 seconds each, represent your thalamus, communicating with your cortex, helping transfer information from short-term to long-term memory storage, while also creating a kind of shield that allows sleep to continue despite minor environmental disturbances. In winter's optimal sleeping temperatures, your brain may generate these protective bursts more reliably, safeguarding your rest more effectively throughout the night. Tiny electrical storms flickering through your sleeping mind, building memories and defending dreams. Circadian amplitude refers to the difference between the peak and trough of your daily biological rhythms, how dramatically your various physiological processes rise and fall across the 24-hour cycle. Research indicates that winter's pronounced contrast between long darkness and short daylight may actually increase circadian amplitude in some individuals, creating more distinct differences between daytime and nighttime physiology. This stronger amplitude means more robust nighttime melatonin peaks, more pronounced nighttime drops in core body temperature, and clearer biological distinctions between sleeping and waking states. While summer's extended daylight can blur these boundaries, winter draws them more sharply, creating a physiological environment where sleep and wake states are more distinctly differentiated, your body's rhythms swinging wider, creating deeper troughs of nighttime rest and higher peaks of daytime wakefulness. When the season provides strong enough time cues, the process of transferring memories from temporary hippocampal storage to permanent cortical networks occurs primarily during sleep, particularly during REM and light sleep stages. With winter's 30 extra minutes of REM sleep and overall longer sleep duration, your brain has extended time for this crucial consolidation work. During sleep, your hippocampus replays the day's experiences in compressed form, essentially teaching your cortex what to remember. This replay happens faster than real time, like watching a video on high speed, allowing many memories to be processed during a single night. Winter's longer sleep periods permit more replay cycles, potentially strengthening more memories or consolidating them more thoroughly. Imagine your brain as a librarian working by lamplight, filing the day's experiences onto permanent shelves, and winter giving that librarian extra hours to complete the cataloging with care. The amygdala, your brain's emotional processing center, shows unique activity patterns during REM sleep, working to process and integrate emotional experiences from waking life. With winter's additional 30 minutes of REM sleep, you may have enhanced capacity for emotional regulation and stress reduction. During REM sleep, your brain appears to strip away some of the intense emotional charge from memories while preserving the informational content, a process that helps you remember what happened without being overwhelmed by how it felt. This emotional regulation function may help explain why adequate sleep improves mood and why sleep deprivation makes emotional regulation more difficult. Winter's REM sleep bonus could provide enhanced emotional processing capacity, precisely when seasonal darkness might otherwise challenge mood. Your dreaming brain gently editing emotional memories, softening their sharp edges while you rest. Your cells build new proteins primarily during sleep, when energy demands from waking activities don't compete with the resource-intensive work of protein synthesis. These proteins are essential for countless functions, repairing damaged tissues, building new cellular structures, creating enzymes and hormones, and maintaining immune function. With winter's longer sleep periods and enhanced deep sleep stages, when growth hormone levels peak, your cells may have extended opportunities for protein synthesis. Research shows that sleep deprivation impairs protein synthesis, while adequate sleep supports it robustly. During winter's extended rest, your cells quietly assembling molecules into the complex protein structures that will support tomorrow's activities. Amino acids linking together in precise sequences, forming the building blocks of life, while winter's darkness provides the time and conditions for this molecular construction work. Your autonomic nervous system has two main branches: sympathetic, which activates fight or flight responses, and parasympathetic, which promotes rest and digest states. During sleep, parasympathetic activity normally dominates, but winter's extended sleep periods mean this restorative state lasts longer each night. Parasympathetic dominance reduces heart rate, lowers blood pressure, enhances digestion, and supports immune function, all the maintenance activities your body performs better at rest. With 14 to 16 hours of darkness supporting extended sleep opportunities, your parasympathetic nervous system may have more time to complete its restorative work before morning's sympathetic activation begins. Think of it as your body's relaxation system getting an extended shift during winter nights, having more time to undo the accumulated tension of waking hours, leaving you more thoroughly restored by morning. During slow-wave sleep, the deepest stage of non-REM sleep, your brain's glymphatic system operates at peak efficiency, clearing away metabolic waste products that accumulate during waking hours. Recent research using advanced imaging techniques has shown that the cerebrospinal fluid flow increases dramatically during slow-wave sleep, washing through brain tissue like a gentle tide. This clearing process removes potentially harmful proteins, including beta amyloid and tau, associated with Alzheimer's disease and other neurodegenerative conditions. Winter's enhancement of deep sleep duration, particularly in men who gain 14 extra minutes, may provide extended waste-clearing time that supports long-term brain health. Your sleeping brain literally washing itself clean, and winter providing extra time for this essential maintenance. The slower your brainwaves, the better this cleaning system works, flushing away the day's cellular debris. Your core body temperature doesn't remain constant throughout sleep, but rather oscillates slightly across sleep cycles, dropping to its lowest point in the early morning hours around 4 or 5 a.m. These temperature fluctuations appear to coordinate with transitions between sleep stages, with slight rises often coinciding with REM sleep periods and drops associated with deep sleep. Winter's cooler ambient temperatures may help support these natural oscillations, making it easier for your body to achieve the temperature nadirs associated with the deepest, most restorative sleep. Research using temperature-controlled bedding found that dynamically adjusting sleeping temperature across the night, cooler early, slightly warmer later, improved sleep quality more than maintaining constant temperature. Winter's natural environment may facilitate these beneficial temperature rhythms without requiring technological intervention, your body finding its own perfect thermal dance. Mitochondria, the energy-producing organelles inside your cells, accumulate damage during waking hours from the very process of energy production. Sleep provides crucial time for mitochondrial repair and regeneration. With winter's longer sleep periods, your cells have extended opportunities for this essential maintenance work. Damaged mitochondria are broken down and recycled through a process called mitophagy, while healthy ones are maintained and, when needed, New ones are created through mitochondrial biogenesis. This maintenance is particularly important because mitochondrial dysfunction contributes to aging and various diseases. Deep sleep stages seem especially important for mitochondrial health, potentially making winter's enhancement of deep sleep particularly valuable. Your cellular power plants receiving extended maintenance shifts during winter's long nights, emerging renewed and ready to fuel tomorrow's activities. Chronotype, whether you're naturally a morning lark or night owl, appears to show some flexibility during winter months. Research on seasonal variations in melatonin timing found greater individual variation in winter circadian phases compared to summer's tighter clustering. This increased variability suggests that winter's extended darkness period allows people's internal clocks to express their natural preferences more freely, unrestrained by summer's early sunrise that imposes morning light on everyone, regardless of chronotype. Some people may drift toward later sleep and wake times, while others maintain earlier patterns, with both being acceptable responses to winter's permissive darkness. Your chronotype expressing itself more authentically during winter, when the season doesn't force a particular schedule, but rather allows your biology to choose its own rhythm within the long dark hours. Cytokines, signaling proteins that coordinate immune responses, are produced at higher rates during sleep, particularly during the first half of the night, when deep sleep stages predominate. Some cytokines, like interleukin-1 and tumor necrosis factor, actually promote sleep while also supporting immune function, creating a beneficial feedback loop where sleep enhances immunity and certain immune signals enhance sleep. With winter's longer nights and enhanced deep sleep, this cytokine production window extends, potentially providing better immune support during the season, when respiratory infections circulate more widely. Sleep deprivation suppresses cytokine production, while adequate sleep supports it robustly. Winter offering your immune system more time each night to produce and distribute the molecular messengers that coordinate your body's defenses, preparing you to face whatever challenges daylight brings. Neuroplasticity, your brain's ability to form new neural connections and modify existing ones, occurs throughout life, but is particularly active during sleep. Winter's extended sleep periods provide more time for these plasticity processes, during which your brain strengthens important neural pathways while pruning less useful ones. Sleep appears to be when your brain consolidates learning, integrating new information with existing knowledge networks. The process involves both synaptic strengthening, where frequently used connections become more robust, and synaptic weakening, where rarely used connections are reduced, making your neural networks more efficient. With winter's additional sleep time, especially the extra REM sleep associated with procedural learning and creativity, your brain may have enhanced opportunities for these plasticity processes. Your sleeping mind quietly rewiring itself, optimizing its networks, becoming slightly different, hopefully better, by morning. Winter providing the extended time this essential neural renovation requires. You're still here, still awake, still drifting with us through winter's secrets. Take a slow breath. Notice how your body feels a little heavier now, as if the weight of sleep is gently settling over you like fresh snow. We're exploring sleep itself together, you and I, and everyone listening in the quiet dark, wandering through science like snowflakes drifting through still air. There's no rush, no destination. Let's continue. Autophagy, the cellular self-cleaning process where damaged components are broken down and recycled, operates most efficiently during fasting and sleep. Winter's longer sleep periods extend the fasting state that naturally occurs overnight, potentially enhancing autophagic processes. During autophagy, cells essentially eat their own damaged parts, misfolded proteins, dysfunctional organelles, cellular debris, and recycle the components into new, useful materials. This cleaning and recycling supports cellular health and longevity. The process requires time and energy, both of which become more available during extended winter sleep when digestive demands are minimal and cellular maintenance takes priority. Your cells quietly tidying themselves through the long dark hours, breaking down what's broken, saving what's useful, emerging cleaner and more efficient by dawn. Your skin undergoes most of its repair and regeneration during nighttime hours when growth hormone levels peak and cell division rates increase. Winter's extended sleep periods provide more time for these restorative processes. Skin cell turnover accelerates during sleep, with new cells replacing damaged ones. Collagen production increases, helping maintain skin structure and elasticity. Blood flow to skin rises during sleep, delivering nutrients and oxygen while carrying away waste products. During winter, when cold air and indoor heating stress skin during waking hours, these extended nighttime repair periods become particularly valuable. The cooler sleeping temperatures of winter may also reduce inflammation in skin tissue, supporting healing processes. Your skin using winter's long nights to undo the day's damage, rebuilding and renewing itself while you dream. Leptin and ghrelin, the hormones that regulate hunger and satiety, achieve better balance with adequate sleep. Winter's naturally longer sleep duration may help optimize these hormonal signals. Leptin, which signals fullness, increases during sleep, while ghrelin, which stimulates hunger, decreases. Sleep deprivation disrupts this balance, increasing ghrelin and decreasing leptin, making you feel hungrier and less satisfied after eating. With winter providing extended sleep opportunities, these hunger hormones may regulate more effectively, potentially explaining why some people find appetite regulation easier during winter months, despite reduced physical activity. Your endocrine system, using winter's dark hours to recalibrate the signals that tell you when you've had enough, when you need more, finding the balance that serves your body's needs. Your blood pressure naturally decreases during sleep, a phenomenon called nocturnal dipping that's important for cardiovascular health. People whose blood pressure doesn't dip adequately during sleep, non-dippers, have higher risk for cardiovascular problems. Winter's cooler sleeping temperatures and longer sleep duration may support more pronounced nocturnal dipping, giving your cardiovascular system extended rest periods. The parasympathetic dominance of sleep reduces heart rate and relaxes blood vessels, allowing pressure to drop. Temperature-controlled sleep studies found improved cardiovascular recovery markers when people slept in cooler environments. Winter naturally providing these optimal temperature conditions, your blood vessels relaxing more deeply, your heart pumping more gently through extended rest periods, pressure dropping like winter barometric readings before a gentle snow. The extra 30 minutes of REM sleep that winter provides may enhance dream recall for people who enjoy remembering their dreams. Dreams occur throughout sleep, but the most vivid, memorable dreams happen during REM periods, particularly the longer REM cycles that occur in the later part of the night. When you wake naturally from or shortly after a REM period, dream recall is strongest. Winter's extended darkness often permits more natural, gradual waking rather than abrupt alarm-driven arousal, potentially allowing you to carry dream memories into wakefulness more easily. The content of winter dreams might also shift subtly, influenced by the season's themes: darkness, cold, rest, renewal. Your dreaming mind weaving stories through the long night and winter's gentle pace, perhaps allowing those stories to linger in memory. Insulin sensitivity. How effectively your cells respond to insulin's signal to absorb glucose improves with adequate sleep and worsens with sleep deprivation. Winter's naturally longer sleep duration may support better insulin sensitivity, helping maintain healthy blood sugar regulation. During deep sleep stages, when metabolic rate slows and glucose demands decrease, your cells appear to restore their insulin responsiveness. Studies have shown that even a few nights of restricted sleep can reduce insulin sensitivity to levels seen in pre-diabetic individuals. Conversely, extending sleep duration can improve insulin sensitivity. Winter's biological encouragement toward longer sleep might provide metabolic benefits, your cells becoming better listeners to insulin's messages during those extra minutes of rest, maintaining the sensitivity that keeps blood sugar balanced and energy steady. Your joints and muscles perform significant repair work during sleep, when mechanical stress is minimal and growth hormone levels peak. Winter's extended sleep periods provide more time for these musculoskeletal repair processes. Cartilage, which has limited blood supply and repairs slowly, relies heavily on overnight restoration periods. Muscle tissue breaks down during exercise and daily activities, then rebuilds during sleep, often becoming stronger in the process. Inflammatory markers in joints decrease during sleep, potentially reducing pain and stiffness. For people with arthritis or other musculoskeletal conditions, winter's longer sleep opportunities might provide enhanced healing time. Your body, using the stillness of winter sleep to mend what movement stressed, rebuilding what activity challenged, preparing your physical structure for another day. Cortisol and other stress hormones that accumulate during waking hours are metabolized and cleared during sleep. Winter's extended sleep duration provides more time for this hormonal reset. While cortisol naturally rises in the early morning to help you wake, it should drop to low levels during the early and middle portions of the night. This overnight reduction allows your stress response system to reset, preventing chronic activation that can harm health. People with insomnia often show elevated nighttime cortisol, creating a vicious cycle where stress hormones prevent sleep, and lack of sleep maintains high stress hormones. Winter's biological invitation toward longer sleep may help break this cycle. Your endocrine system given sufficient darkness and rest to fully clear the day's stress hormones, starting each morning with a fresher slate. Your liver and kidneys perform crucial detoxification work continuously, but certain detox pathways operate more efficiently during sleep's fasting state. Winter's longer sleep extends this fasting period, potentially enhancing detoxification. The liver processes and neutralizes toxins through two-phase systems that work best when not competing with active digestion. Your kidneys filter blood and concentrate waste more efficiently during sleep's reduced metabolic state. Additionally, the glymphatic system clearing brain waste represents a form of neural detoxification unique to sleep. These combined detoxification processes may operate more thoroughly during winter's extended rest periods. Your body's cleaning systems given more time to process and remove the accumulated byproducts of metabolism and environmental exposure, quiet cellular janitors working the night shift, and winter extending their hours. Across human cultures and throughout history, winter has been recognized as a season for increased rest and reduced activity. Traditional Chinese medicine describes winter as the time of kidney energy and water element, associated with rest, storage, and conservation. Ayurvedic medicine recommends longer sleep during winter's kapha season. European agricultural traditions organize work around seasonal daylight, with winter months devoted to indoor crafts, storytelling, and extended sleep. Indigenous Arctic peoples adapted their entire lifestyles to extreme photoperiod variations, sleeping longer during dark months. This cross-cultural wisdom, accumulated across millennia, aligns remarkably well with modern sleep science, showing winter's biological encouragement toward extended rest. Different traditions, same truth. Winter is for sleeping. Your eyes work constantly during waking hours, focusing, tracking movement, adjusting to varying light levels. Winter's shorter daylight hours mean less time straining eyes, while extended darkness provides longer recovery periods. The muscles controlling your lenses relax during sleep, and tear production patterns change to maintain eye health. Blue light exposure from screens, particularly problematic for circadian rhythms, also represents a form of retinal stress that accumulates during waking hours. Winter's early darkness naturally limits evening screen time for those following natural light-dark cycles, potentially reducing both circadian disruption and eye strain. Modern life may keep screens glowing regardless of season, but winter still offers the opportunity for earlier darkness and longer eye rest, allowing the intricate structures of your visual system time to recover. Your bones constantly remodel themselves through balanced processes of bone resorption and bone formation. This remodeling occurs around the clock, but follows circadian patterns, with certain aspects more active during sleep. Growth hormone, which peaks during deep sleep, stimulates bone formation. Calcium absorption and incorporation into bone tissue also follow daily rhythms. Winter's extended sleep periods, particularly the enhanced deep sleep stages, may provide additional time for bone-building processes. This becomes particularly important during winter, when outdoor activity often decreases and vitamin D levels drop, both factors that can challenge bone health. Your skeletal system using winter's long nights to maintain its structure, calcium atoms finding their places in bone matrix, microscopic construction work continuing while you rest, building the framework that supports you. Your lymphatic system, which clears cellular waste and supports immune function, relies on movement to circulate lymph fluid. It lacks a pump like the circulatory system's heart. During sleep, body position and gentle breathing movements help lymphatic drainage. Winter's tendency toward curled sleeping positions may support certain drainage pathways, while the parasympathetic dominance of sleep enhances lymphatic circulation. Research suggests that sleeping on your side may particularly support brain lymphatic drainage through the glymphatic system. The stillness of extended winter sleep, combined with relaxed muscle tone and optimal sleeping temperatures, creates conditions where lymphatic fluid can move more freely through its network of vessels and nodes. Cellular waste slowly draining away through the night, your lymphatic system working quietly in the stillness. For people with seasonal affective disorder, the timing of sleep becomes particularly important during winter. Light therapy, the primary treatment, works best when administered in the early morning, essentially providing an artificial dawn that helps advance circadian phase. This therapy is most effective when combined with consistent sleep-wake schedules that align with treatment timing. Interestingly, some research suggests that people with SAD might have circadian rhythms that naturally run later than the external light-dark cycle, and winter's extreme photoperiod exacerbates this misalignment. Understanding your own circadian preferences during winter can help you work with rather than against your biology. Some people benefit from slightly later sleep schedules during winter, while others need earlier bedtimes. Winter inviting you to listen to your body's natural rhythms. During winter, when your eyes adapt to lower overall light levels, even small amounts of bedroom light can disrupt melatonin production more significantly than during summer. Light from street lamps, electronics, or hallways that might seem negligible becomes more disruptive when your eyes have spent shorter days in dimmer conditions. Research shows that room darkening curtains or blackout shades can improve sleep quality, particularly during winter, when the contrast between darkness and any light source is more pronounced. Your pupils dilate more readily in winter-adapted eyes, gathering more light from dim sources. Creating a truly dark sleeping environment supports melatonin production and reduces the chance of light-triggered wakings. Winter darkness teaching your eyes to treasure true blackness, to rest in absence of light. Your gut microbiome, the trillions of bacteria living in your digestive system, shows daily rhythms influenced by meal timing, sleep-wake cycles, and probably seasonal patterns too. These microbes help regulate metabolism, immune function, and even mood through their interactions with your nervous and endocrine systems. Some species are more active during sleep's fasting period, performing functions that support gut barrier integrity and produce beneficial metabolites. Winter's extended sleep and fasting periods may influence which microbial species thrive, potentially shifting the overall composition of your gut community. The relationship between sleep and microbiome is bidirectional. Your sleep affects your microbes, and your microbes affect your sleep through various signaling molecules. Microscopic communities within you also following winter's rhythms, adapting to the season's extended rest. The extended REM sleep of winter, when most vivid dreaming occurs, may influence creative thinking and problem-solving. REM sleep has been linked to enhanced creativity, pattern recognition, and insight. Artists, writers, and inventors throughout history have reported breakthrough ideas emerging from dreams or the hypnagogic state between sleeping and waking. Winter's additional 30 minutes of REM sleep might provide extra opportunity for the kind of mental processing that supports creative insights. The long, dark hours also historically provided time for indoor creative activities, storytelling, music, crafts that complemented rather than competed with extended sleep. Your dreaming mind making unexpected connections during winter's extended REM periods, weaving together ideas in ways your waking consciousness never would, solving problems while you rest. Modern technology allows sophisticated control of sleeping temperature through devices like temperature-controlled mattress covers. But winter has always provided a natural version of this optimization. The temperature gradient that supports sleep, cool environment, warm body under covers happens organically during winter. Historical sleeping arrangements, from shared warmth in cold rooms to specialized winter bedding, reflect humanity's long adaptation to seasonal sleeping conditions. Today's technology essentially automates what winter once provided naturally: the cooling of the first sleep half, slight warming toward morning, and the comfortable temperature differential between air and covered body. Winter, as the original temperature-regulated sleeping system, perfected through millions of years of mammalian evolution, now being mimicked by modern devices. Winter nights tend to be quieter than summer nights in many environments. Fewer insects buzz, fewer birds call at dawn, less activity outside. This seasonal silence may contribute to winter sleep quality by reducing acoustic sleep disruptions. Research shows that sudden noises can fragment sleep even when you don't consciously wake, and that consistent, quiet sleeping environments support better sleep architecture. The snow, muffled quiet of winter, the stillness of cold air that dampens sound, creates naturally peaceful conditions for sleep. Of course, urban environments maintain constant noise regardless of season, but in places where natural soundscapes still dominate, winter offers a hush that supports rest. The world outside, growing quiet, matching the inner quiet of sleep. Your body's hydration needs change with seasons, and winter sleep patterns may influence fluid balance differently than summer sleep. During sleep, you continue losing water through breathing and minimal sweating, but winter's cooler temperatures reduce these losses compared to summer. Additionally, winter's drier air, particularly in heated homes, can increase respiratory water loss, even as skin water loss decreases. Adequate hydration supports all the cellular processes that occur during sleep, from waste clearance to protein synthesis. However, excessive evening fluid intake can disrupt sleep with nighttime bathroom visits. Winter's balance point, enough hydration to support overnight processes without disrupting sleep, may differ from summer's needs. Your body, adjusting its fluid management to the season, finding the equilibrium that serves both sleep and cellular function. Shorter winter days and potential sleep pressure from earlier darkness might make daytime napping more tempting during winter months. Short naps, 20 to 30 minutes, can provide rest without entering deep sleep stages that might cause grogginess upon waking or interfere with nighttime sleep. However, longer or later day naps might reduce nighttime sleep pressure. Interestingly, some research on populations living at extreme latitudes suggests that winter might naturally support polyphasic sleep patterns with a main nighttime sleep period supplemented by daytime rest. Before electricity, winter's long dark mornings and early dark evenings may have encouraged this pattern. Today's schedules often prevent it, but winter's biology might still incline some people toward occasional brief daytime rest to complement extended nighttime sleep. Cold air transmits sound differently than warm air, with temperature affecting both speed and quality of sound propagation. Winter's cold nights create unique acoustic properties. Sound may travel further in cold air, but snow and ice absorb and dampen many sounds. These seasonal acoustic changes might subtly influence sleep quality in ways we rarely consciously notice. The crunch of snow underfoot, the silence after fresh snowfall, the particular quiet of very cold nights. These sonic signatures of winter create a unique auditory environment. For people living where winters bring genuine cold and snow, these seasonal sounds might become associated with sleep and rest through repeated winter experiences. Your ears learning winter's particular silence, your mind associating it with rest and renewal. Beyond its role in sleep regulation, melatonin functions as a powerful antioxidant, neutralizing harmful free radicals throughout your body and brain. Winter's extended melatonin production thus provides not only sleep benefits, but also enhanced antioxidant protection during the season's long nights. Melatonin can cross cellular membranes easily, reaching areas other antioxidants cannot, and it doesn't become a pro-oxidant after neutralizing free radicals like some antioxidants do. This means winter's extended melatonin exposure offers prolonged antioxidant protection during the hours when cellular repair processes are most active. Your pineal gland producing a molecule that both invites sleep and protects sleeping cells from oxidative damage. Winter extending both functions by extending darkness, a dual gift from the season. Sleep talking, or somniloquy, typically occurs during transitions between sleep stages, rather than during the deepest sleep. Some people report less sleep talking during winter, possibly because cooler temperatures and extended darkness support more stable, deeper sleep, with fewer stage transitions. However, the increased REM sleep of winter might affect dreams in ways that increase REM-related sleep talking in other individuals. These phenomena vary greatly between people, but the seasonal patterns of sleep architecture, more deep sleep for some, more REM for others, generally more continuous sleep overall, may subtly influence how often these parasomnias occur. Your sleeping mind occasionally speaking outward, and winter's deeper sleep perhaps quieting these nocturnal utterances, holding consciousness more steadily in rest's silent realm. Your body's preparation for sleep actually begins hours before you lie down, with processes triggered by evening light changes. During winter, when sunset occurs much earlier, sometimes as early as 4:30 or 5 p.m., this sleep preparation begins correspondingly earlier. Your body doesn't distinguish between clock time and biological time. It responds to light levels and other environmental cues. This means that on winter afternoons, even while you're still active and alert, your biology has already started shifting toward evening physiology, slightly lowering core temperature, beginning melatonin production ramp up, adjusting hormone levels. By the time you actually go to bed, your body has been preparing for hours, perhaps explaining why falling asleep often feels easier on winter evenings. the season giving you extended runway for sleep's approach. And now, halfway through our journey, let each breath guide you to realize time is yours, a separate stream that only you are living. While the seasons continue to spin, winter arriving, spring following, summer warming, autumn cooling, this moment you're breathing, listening, is unique. Notice the stillness of wintertime, how it feels slower, deeper, more spacious. Cherish the present moment, knowing that right now, your time is perfectly aligned with nature's ancient rhythm. You're exactly where you need to be, drifting in this peaceful winter darkness. And we continue drifting. Many ancient cultures recognized winter sleep as sacred time, not merely biological necessity but spiritual opportunity. The long, dark hours offered space for dreams, visions, inner work. Modern science confirms what mystics knew. Sleep transforms consciousness, processes emotions, consolidates wisdom. Winter simply provides more of this transformative time. Your ancestors knew to honor winter rest, to see extended sleep not as laziness but as essential work of a different kind, the darkness holding you gently, offering time to become. Strange perhaps that cold should comfort, but winter sleep teaches this paradox. The cool air on your face, the warmth beneath blankets, this contrast creates safety. Your body nestled secure, protected from the cold, held by warmth. Temperature itself becomes a lullaby, the differential between outer and inner, creating the conditions where consciousness can release. Like animals in dens, you burrow into warmth, while winter's cold stands guard outside. The ancient comfort of shelter, of warmth, earned against cold. Light has been called medicine, and truly it is, for mood, circadian health, wakefulness, but darkness too is medicine, healing what light cannot. Darkness resets, restores, allows the inward turn. Winter offers this medicine in generous doses, extended hours of dark like an extended dose of healing herbs given freely by the season. Your eyes resting in absence of light, your pineal gland releasing its nighttime elixir, your whole being drinking darkness like thirsty earth drinks rain. Essential medicine. This darkness, this rest. Everything slows in winter. Metabolism, movement, the very pace of days. Your sleep reflects this seasonal slowing. Breath deepens and slows. Heartbeat softens and steadies. Brainwaves lengthen into slow rolling delta rhythms. Time itself seems to stretch and slow in winter's long nights, each moment of sleep somehow fuller, deeper, the hurried quality of summer sleep replaced by this slower, more thorough rest. Your body learning winter's essential lesson, sometimes slower is better, deeper is richer. Winter offers you a gift, more sleep, deeper rest, extended dreams. You can refuse it. Maintain summer schedules through winter darkness. Many do. But you can also accept, aligning your rest with seasonal rhythms, allowing winter's invitation to actually guide your sleep. The gift is offered freely, no payment required, just acceptance. Just the willingness to sleep when darkness suggests sleeping, to rest when cold suggests resting, to receive what winter offers without guilt, without resistance, simply with gratitude. Your DNA carries millions of years of seasonal sleeping patterns. Every winter your ancestors survived, every long dark night they slept through, lives on in your genes. The mechanisms that lengthened their sleep as days shortened still operate in you. Modern life may obscure these patterns, but winter still whispers its ancient invitation, still triggers those old biological programs. When you sleep longer in winter, you're not being lazy, you're being ancient, being exactly what you've always been, a creature of seasons, responding as your kind has always responded. Melatonin, serotonin, GABA, adenosine. These molecules orchestrate your winter sleep, each playing its part in the chemistry of rest. But together, they create something beyond mere biology: peace. The feeling of ease as sleep approaches, the gentle release of consciousness, the quiet joy of rest. Chemistry creating experience. Winter's extended darkness conducts this chemical orchestra longer, allowing the symphony of sleep molecules to play extended arrangements. Your brain bathed in peace, inducing chemistry, surrendering to their invitation, finding rest in their molecular embrace. Sleep is your nightly time machine, moving you from yesterday to tomorrow without conscious passage. In winter, this journey lengthens. You board the vessel of sleep in evening darkness and emerge hours later, having traveled through night without experiencing its passage. The winter sleep journey simply takes you further, through more hours of clock time, though the subjective experience remains timeless. You enter sleep in one moment, exit in another, with all the time between somehow both existing and not existing. Winter extending this magical disappearance. Your body has always been an economist, managing energy budgets carefully. Winter's extended sleep makes economic sense. Conserve energy during times of scarcity, rest when resources are limited. This ancient calculation still runs in your cells, recommending rest even when modern life provides abundant food and warmth. The biological economist within you still believes winter requires conservation, and perhaps it does, just of different resources now. Conserving attention, energy, enthusiasm for the eventual return of spring. Winter sleep as savings account, storing rest. Winter dreams may feel different, longer, stranger, more vivid. Perhaps the extra REM time allows dreams to develop more fully, to explore themes more thoroughly. Or perhaps winter's darkness, its coldness, its stark beauty somehow seeps into the content of dreams themselves. Your unconscious mind weaving winter into its nightly stories. Landscapes of snow, darkness, cold, rest. Dreams becoming seasonal, reflecting not just personal psychology, but also the world's present state. Your sleeping mind painting with winter colors, telling winter stories. Winter gives extra sleep to everyone, not just those who can afford it, not just the privileged, but freely to all who allow it. Rich and poor alike feel winter drowsiness, experience earlier darkness, benefit from extended melatonin. Nature's gift of rest distributed equally, one of the few resources not rationed by wealth or status. The same darkness falls on all houses. The same cold encourages all bodies toward rest. In this at least, winter practices perfect fairness. The democracy of darkness, the equity of seasonal sleep. Spring will bring longer days, summer even more light, heat, activity. But right now, winter, your body knows what those seasons don't, that rest comes before growth, darkness before light, sleep before waking. Winter sleep prepares you for spring energy, storing the rest that will fuel future activity. Your body wise enough to use this season for what it offers, knowing that spring's demands will come soon enough. Right now, winter. Right now, rest. Right now, the wisdom of sleeping while darkness invites sleeping. If winter sleep had a sound, perhaps it would be this: slow breath in cold air, the gentle rustle of heavy blankets, the particular silence of snow-muffled nights. Or perhaps the sound of your own heartbeat, slowed and steady, pulsing through pillow into ear. The internal sounds of sleep, breath, pulse, the occasional sigh, these become winter's lullaby. External silence, internal rhythm, the music of rest playing softly through the long dark hours, your body's quiet nighttime symphony. Fighting winter is exhausting. Maintaining summer schedules, resisting longer sleep, forcing brightness into darkness. Surrender is easier, not defeat, but acceptance, allowing winter to be winter, darkness to be dark, sleep to lengthen naturally. This surrender doesn't mean passivity in all things, just recognition that some rhythms are larger than personal will, some cycles worth joining rather than resisting. Your biology wants to surrender to winter. Perhaps letting it does no harm. Perhaps surrender, in this case, is wisdom. How many billion winter sleeps have humans experienced? How many trillion hours of winter darkness, winter dreams, winter rest? An archive of sleeping stretching back through time, connecting you to every person who ever surrendered to winter's invitation. You're not alone in this sleep. You're part of the great archive of winter rest, adding your own hours to humanity's accumulated seasonal slumber. Every winter, sleep a contribution to this vast collection. Your rest tonight linked to all the winter rests that came before. Temperature slightly lower, darkness slightly longer, sleep slightly deeper. These small winter adjustments create surprisingly large effect. An extra 30 minutes of REM sleep might seem minor, but across a winter season, it accumulates to 15 hours of additional dream time. 10 extra minutes of sleep per night becomes 50 hours across a winter. Small differences, repeated daily, compound into significant totals. Winter's gentle nudges toward longer sleep, creating substantial rest benefits through simple accumulation. Mathematics of rest, economics of sleep. True hibernation, months of suspended animation, remains impossible for humans, but winter sleep hints at distant cousins of this ability. The extended rest, lowered metabolism, deeper relaxation, pale echoes of hibernation's profound retreat. Perhaps your winter's sleep represents humanity's gentler version of what bears and groundhogs do more extremely. Same impulse, different degree. The biological imperative to rest during cold darkness, expressed according to your species' particular design. Your DNA containing traces of more ancient sleep patterns. Winter sleep has a particular texture, quality, feel, heavier somehow than summer sleep, denser, more substantial. Like the difference between light cotton sheets and heavy wool blankets, summer sleep versus winter sleep feels different in some essential way. Perhaps the extra deep sleep creates this sense of weight, or the extended melatonin exposure, or simply the psychological associations with winter, rest, retreat, restoration. Whatever the cause, winter sleep often feels more solid, more real somehow, a different quality of unconsciousness. You have permission to sleep more in winter, permission to go to bed earlier, wake later, nap when drowsy, permission to follow darkness rather than fight it, to rest when biology suggests resting. This isn't medical advice, but biological observation. Winter invites longer sleep, and accepting that invitation does no harm. You're not lazy, you're not depressed, though if you are, that's separate. You're just seasonally appropriate. Give yourself permission to be a creature of seasons, to rest when winter suggests resting. Winter teaches patience if you let it. The patience to lie in darkness waiting for sleep. The patience to let sleep last its full course. The patience to move slowly through dark mornings. Hurrying fights winter's essential nature. The season asks you to slow down, be patient, allow processes their full time. Your sleep benefits from this patience, waiting for natural drowsiness rather than forcing sleep, allowing natural waking rather than alarm shocking yourself alert. Winter as patience teacher, if you become its student. Throughout this journey, you've learned how winter changes sleep. More REM, more deep sleep, longer duration, cooler temperatures, extended melatonin, vitamin D's role, ancient patterns, modern research. All this knowledge, integrating now into simple understanding. Winter helps you sleep better by making nights longer, temperatures cooler, and your biology more inclined toward rest. The science complex, but the conclusion's simple. Winter is for sleeping. Trust it. Before we complete this journey, winter extends one more invitation. Not to remember all you've learned. You can forget these facts entirely. But to remember this, your body knows how to sleep, knows when to sleep longer, knows to follow darkness into rest. Winter simply gives your body more opportunities to do what it already knows how to do. Accept the opportunities. Follow the darkness. Let sleep come. Winter whispers, an ancient lesson your body never forgot. Rest deeply, restore completely, trust darkness. When spring arrives, you'll have the energy stored from all this winter dreaming. The cold teaches warmth, the dark teaches light, the stillness teaches movement. Your winter sleep prepares you for summer wakefulness, though you don't need to think about that now. Just rest, just dream, just be. All these facts, all this science, really just confirms something simple. Your body already knows. It knows to sleep more when nights are long. It knows to rest when temperatures cool. It knows to dream when darkness extends. You don't need to remember any of this. Your cells remember. Your genes remember. Billions of years of evolution remember. Trust that ancient wisdom now. And so we arrive at the final truth. Winter gives you permission to rest deeply, sleep longer, dream richer. Not because something's wrong, but because something's profoundly right. Your body sleeping more in winter isn't a problem to fix, but a gift to receive. Accept that gift now. Let winter wrap you in its dark, cool, dreaming embrace. This is exactly what you need. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. Winter arrives. Spring follows. Summer warms. Autumn cools. Winter returns again. All are circles, cycles, endless rhythms, like your breath. Inhale, exhale, inhale, exhale. A small cycle within the vast universe of seasons. You are also part of that eternal movement. You don't need to hold on to anything. Let everything unfold in its perfect order, like seasons silently rotating in their orbits, unhurried, unresisting, simply existing. We're almost there now, and so, our quiet journey through winter's sleeping wisdom comes to a gentle close. We've traveled from the chemistry of melatonin rising in your brain to the cellular responses to cold that guide you into dreams, discovering along the way that winter sleep is nature's perfect restoration. From vitamin D synthesis in summer sunlight to REM sleep extension in winter darkness, we've glimpsed how seasonal rhythms are both ancient and immediate, both cosmic and cellular. Winter reminds us that rest is not laziness, but wisdom. Much of the restoration your body needs happens in silence, in darkness, in the cool stillness of extended sleep. The seasons teach us acceptance, rhythm, trust in natural cycles. Without winter's invitation to slow down, we would burn too brightly, too constantly. By pausing to notice, we glimpse the extraordinary in the ordinary. And now, in these final minutes, take the deepest breath you can, as deep as possible. Think about how water cycles through clouds, rivers, oceans, and rain. Everything is connected, everything returns, everything flows through seasons. You are part of that flow, that cycle, that eternal return. Winter sleep, spring awakening, summer energy, autumn release. Let your entire being dissolve into the rhythm of nature, into the breath of the seasons, into stillness. Prepare for deep sleep. No boundaries left, only peace. If this gentle journey through winter's wisdom brought you peace tonight, perhaps share it softly with someone else who's searching for stillness in the cold season. It might be exactly what another restless mind needs to finally let go and drift. One quiet share, one peaceful night at a time. But there's no need to do anything now. Nothing at all. You've traveled through winter's deepest secrets tonight. farther than most journeys take you. You can allow these thoughts of seasons and sleep to fade now, like morning mist dissolving in the first light of dawn, leaving only the quiet calm behind. Let your breathing deepen. Let your body feel heavier, as if gravity itself is gently pulling you into the earth's warm embrace. If sleep comes, let it carry you like snowfall, softly, inevitably, into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, winter will still be there. The seasons will still be turning. But tonight belongs to stillness. Rest well, sleepy scientist. And remember, winter's cold darkness isn't something to endure, but something to embrace. Dream deeper with bedtime science. Good night.